Hey guys, so in this video, I'm going to show how we can derive the probability distribution for a random variable x and how we can calculate the expected value of x as well as the expected value of a function of x, let's say x squared. So if you're asked to derive the probability distribution for a random variable x, how are you going to go about it? And in this short video, I'm going to explain the steps that you need to follow in order to obtain the probability distribution and then use the results to calculate the expected value of x as well as to calculate the expected value of a function of x, that is x squared. Okay, so in this video, for illustration purposes, I'm going to solve the exercises given in the textbook Dougherty. So in the review chapter, you'll find exercises number R2, R4, and R7. These three are interconnected. So we're going to use the example given in these exercises. So x has been defined to be a variable, which is the larger of the two values when two dice are thrown, or when the values are the same, then the value itself. So let's say we have two dice, one is red and the other one is green. And let's say if we throw these two dice together, on the red die we get 3 and on the green die we get 1, then x is going to be equal to 3. And let's say if we throw the dice again, and in this situation, let's say on the second throw, we get 3 on the red die once again, and we get 3 on the green die as well. Then in this case, x is going to equal 3. So x is going to be 3 here as well as 3 here. So that's pretty straightforward. Let's move on. Okay, so how are we going to go about deriving the probability distribution for x? Step 1 is simply to draw a table of all possible outcomes. That is, we are going to list all the possible values that x can take. So to do that, we simply draw a table as follows. And I'm going to draw this table as neatly as I possibly can. Right. Let me also quickly draw these lines so that it's not jumbled up. Okay, that's as straight a line I can draw as possible. Right. So, okay. So when x takes on, so when we throw the two dice together and the red die gives us the value 1 and the green die gives us the value 1 as well, we know that x is going to equal 1, right? And when the red die gives us a value of 2 and the green die gives us a value of 1, we know that x is going to equal 2 because it's the larger of the two values here. So we can fill in the whole table very quickly. Let me just do that. And if you're not sure how I'm doing this, you simply have to recall the definition of the random variable x, which we defined at the start of this video. Okay, cool. So that's going to be 2, 2, 3, 4, 5, 6. This is going to be 3, 3, 3, 4, 5, 6. This is 4, 4, 4, 4, 5, 6. This would be 5, 5, 5, 5, 5, 6. And finally, in the last row, we have 6 throughout. Okay, cool. Now that we have this table, we can draw another table, and that is going to be table number 2. Okay, I'm just going to draw it on this side. So step 2 is to draw another table. And in this table, what we're going to do is, in the very first row, we're going to list down all of the values, the range of values basically that x can take. So from this table here on the left hand side, we can note that x can be any of the numbers from 1 to 6, right? So first of all, I'm going to list down 1, 2, 3, 4, 5, and 6 because x can take on any of these numbers, right, between 1 to 6. So that's pretty straightforward. And in the next column, let me just draw a straight line. Okay, that's straight enough. I hope so. So in the next column, I'm going to note down the frequency with which x takes on a particular value. So f over here denotes frequency, okay? So we can see that in this second column, we're going to note down the frequencies associated with the possible values of x. So for example, when x takes on the value of 1, we can see that that happens just once, right? Because if you look at the table, we see that 1 appears only once. So over here in this column, I'm going to write 1 because 1 is denoting the total number of times that x takes on the value of 1, okay? So I repeat, basically, this column of frequencies shows the frequencies associated with the possible value of x. So for instance, x takes on the value of 2 a total of 3 times, right? And in order to get the frequencies, you simply have to count. So if you look at the table, we see that x takes on the value of 2 only 3 times. So I note that the frequency is 3 over here, and then we simply keep counting. So we see that x is equal to 3 a total of 5 times, x is equal to 4 a total of 7 times, x is equal to 5 a total of 9 times, and x is equal to 6 a total of 11 times. Also, let me just change the color of this particular line because, okay, let's just erase it. And let's use another color, maybe blue. Okay, I think yellow should be a better color. And yeah, that's better. So this is our second table over here. Okay, now in the third column, we finally obtain the probability distribution, that is the probabilities that we're going to associate with the specific particular values of x. Right. Let me just change that color again. So this was supposed to be in white. Cool. Now, in order to do that, we have to note the fact that we have already worked out the frequencies, right, for all of the values of x. So how do we obtain the probability? Now, this is important. In order to derive the probability of obtaining each value of x, the probability distribution is simply obtained by counting the number of times each outcome occurs, that is, by using these frequencies that we've already obtained, and then dividing that number by 36. Now, I know that this sounds a little bit overwhelming, but basically what we're saying is that you take this frequency that is 1 and you divide it by 36. And the reason we're dividing this frequency by 36 is because, remember, 36 was the total number of possible outcomes in this particular result, in this particular table. So we divide 1 by 36. Similarly, we divide 3 by 36, and then we divide 5 by 36, and we divide 7 by 36, 9 by 36, and 11 by 36. Okay, so I repeat, the probability distribution is derived by counting the number of times each outcome occurs and dividing it by 36. So for each value of x, we have obtained the probability of obtaining that particular value of x. Now, finally, what we're going to do next is we're going to multiply the value of x with its associated probability. So for instance, here, when I multiply 1 by 1 over 36, I get 1 over 36. And here, when we get 2, then 2 into 3 is equal to 6 over 36. Similarly, in the third row, we have 3 into 5, which is 15 over 36. And then we have 4 into 7, which is 21 over 36. And sorry, 4 into 7 is 28 over 36. And then we have 45, 9 fives are 45 over 36, and finally we have 66 over 36. Now, why are we doing that? Well, if we look at the formula for calculating the expected value of x, we know that the expected value of x can be obtained by simply adding up all of these values in the fourth column. So when we do that, that is when we add up all of these values together, we are going to get, well, 1 plus 6 plus 15 plus 28, because the denominator is 36, so it's common for all of the values. So it's going to equal, let me just use my calculator very quickly. Okay, so this is going to equal 161 over 36, and that equals 4.47. Now, what we've done here is, first of all, in step one, we created a table of all possible outcomes, and using the results in that table, we obtained the probability distribution for x. Okay, and then once we obtained the probability distribution for x, we used those results to calculate the expected value of x, which equals 4.47. And how did we do that? Well, we simply multiplied the values in the first column with the values in the third column, and when we do that, we obtain the weighted values, right? Because remember, the expected value of x simply means the weighted average, right? So this gives us 1 over 36 for the first row, and then all we do is that we add, that is sum up all of these values in the last column, and we get 161 over 36, which equals 4.47. So the expected value of x is equal to 4.47. Okay, so the table that I had drawn was not at all neat, so I have redrawn the table, and in the first column right here, we have the values for x, that is ranging from 1 to 6. In the second column, we have the frequencies associated with each value of x. In the third column, we have the probability distribution for x, and in the fourth column, we have simply multiplied the values in the first column with the values in the third column to obtain the weighted values of x. So these right here in the fourth column are the weighted values. And if you don't understand what that means, you need to watch my video on what we mean by the expected value of x. So when we sum all of these values in the fourth column, we get the expected value of x, which is basically the mean denoted by mu x, and 161 over 36 is equal to 4.47. So the expected value of x is obtained simply by adding up all of these values in the fourth column. So this gives us the weighted average, not a simple average, but the weighted average. Okay, so I'm going to leave a link in the description box below where I explain what we mean by weighted average. Next, in the fourth column and in the fifth and the sixth columns, what we have done is, now next we are trying to compute the expected value of x squared. This is required by exercise number R7 in the review chapter from Dougherty. So how do we do that? Now note that x squared is simply a function of x, right? So first of all, we need to calculate x squared, which is done in the fifth column. So we take the values in the first column and simply square them. So the square of 1 is simply 1, and the square of 2 is 4. So the fifth column is filled up very quickly by squaring the values in the first column. And finally, so these are the squared values of x. And finally, in the sixth column, what we've done is we've multiplied the values in the, we've multiplied the values in the fifth column with the values in the fourth column. So let me just change the color. So we've multiplied the values in the fifth column with the values in the fourth column to obtain the values in the sixth column, right? And that gives us basically x squared times the probability. So once again, once we have filled out all of these values in the sixth column, we can simply add them up, and this time this is going to give us when we add these up, this is going to give us the expected value of a function of x, that is the expected value of x squared, and that equals 791 over 36, which is equal to 21.97. So the expected value of x squared is equal to 21.97. Okay, I'm sorry about the mess, but my pen is giving me a really hard time. Okay, thank you for watching.